Rahim. Welcome to the lecture number 12th lecture number 23. In the previous lecture, we have completed overall heat transfer coefficient and as well as overall heat thermal resistance. But that thermal resistance also include the area. But in this, when we are talking about the resistance, overall resistance in overall heat transfer coefficient U factor, the area is not included in the resistance, so it will come into the formula of heat transfer formula, that becomes UA T minus TO. And Ti temperature could be internal temperature and TO could be the outer temperature of the wall. If the outer temperature will be higher, so it becomes TO minus Ti. And if we are talking about the winter season, the formula remains same Ti minus To, because internal temperature is around 22 degrees centigrade and outer temperature will be in minus or very low temperature like 7-8 degrees centigrade. So U will be the overall heat transfer coefficient. That is also included the thermal conductivity, L over Ka, like in conduction heat transfer, the resistance value, the resistance formula become L, thickness over thermal conductivity, L over K. And if we are talking about the convection, it will become 1 over H, because area is not included the resistance. So resistance formula like this. And if we talking about the overall heat transfer coefficient, the 1 over R will be the U. You can write this R is equal to 1 over U, or U is equal to 1 over R. Anyway, most of the material are differentiate with the U value. You will find when you are building any homes or any building, you will be facing the with the properties of the material with the U value. So you can easily recognize it is basically what it consists of, the overall heat transfer coefficient that can be included of conduction, convection, and as well as radiations. Okay, let's do one numerical which is left in our previous lecture. So you will get better understanding of U value and thermal resistance, equivalent thermal resistance of different materials. When we sum of all resistance, we can easily calculate the U value, and we can easily also calculate the heat transfer rate without knowing the internal temperature of the materials. Okay, we already talk about that the exterior wall have U value differentiate. Like if we are polymer cracking mortar, it is 0.93, self insulation wall is 0.1, calcium silicate board is 0.20, the roof material, waterproof material have 0.9, autoclave lightweight concrete have 0.130, and the ground level surface also have different U value with respect to different thickness. Okay, so now move on. This is the tables we already done in previous classes, that these tables telling us the emissivity value of in terms of radiation. We are calculating the radiation effects also. We also want to know the emissivity values, and from the emissivity value we can easily calculate the resistance of the radiation due to the resistance due to the radiations. Now let's cut the camera. And also the U value of different construction material that will be used in upcoming numerical. So now come towards the example 3.16, in which we have I just especially take this numerical due to your correlation with your in chemical civil engineering. Beside this, we also have many numerical related to the U value and overall thermal resistance, like electronics system, boards, etc., mechanical system, etc. So there are many examples. So I just take the example which relate to your civil engineering, which is related to your discipline. Anyway, we already read out the numerical in our previous lecture. Let's just get done again. Determine the overall unit thermal resistance R value and the overall heat transfer coefficient U factor of the wood frame. That we have a wood frame building, the build around the 38 by 90 millimeter nominal wood studs. This is wood stud. Center to center distance is 400 and 90 millimeter cavity between the studs filled with the glass fiber. This is basically a glass fiber insulation glass fiber. The inside finish is 30 millimeter gypsum wall. This is the inside. uh, inside the wall is covered with the gypsum board. It is also used in Karachi. You can see in many malls the lights are placed with the gypsum boards, and we have a very beautiful aesthetic design with the gypsum board. You can go through any buildings, malls. A lot of work has been done with the gypsum board. It can be easily shaped into different ways. Okay, so and it is also very finished material. So the paint, when we apply paint over here, there will be no any lines and shrinks etc. So the outer side the outer side is 13 millimeter fiber board. This is the fiber board. This also provide the stable material between the insulation. Okay, and fiber board and the outer surface will be bevel lap. You can see the shape. This is called bevel lap. Most of the woods outside in European countries like UK and many Austria, and also the cold the areas which have a very cold temperature are covered with or construct with the wood material. So outside surface also consists of this kind of a lab material. It gives good aesthetic looks and also good insulation to the building, and also the strength to the building. Okay, so the outer surface is covered with the bevel lab sliding. The insulated cavity consisted of 75% of the heat transmission, while the stud constitute 21, header constitute 4%. So the 70% of the walls are consist of this insulation, this glass fiber insulation, and only 21 we can constitute it to 25, because it consisted as threads and heads both. So 21%, 25% consists of this heat transfer due to this stud, and 75% consists of this insulation. Also determine the heat loss to the walls. House perimeter is 50 meter, and the wall height is 2.5. Las Vegas, Nevada, whose winter design is -2, and the inside temperature to be 22 degree, and assume 20% of the wall is occupied by the glazing. What means that on 100, if we are talking about the 100% heat transfer, we can just calculate only 80% from this material, and the 20% of the home is consist of glazing, like walls, glass, we have walls etc. So 20% consists of the windows, like glass window, double glass windows. So they didn't just give information of glazing like windows, so we are not take this 20%. We just calculating the 80% heat transfer through this walls. Okay, so the overall heat transfer resistance will be 1 over overall heat transfer coefficient, and the overall heat transfer coefficient will be the consist of U factor of insulation area and U factor of stud. Okay, and F is the area that insulation area is covered with 75% and the stud considered with 25%. Okay, so it is written also this here. F is just nothing but the percentage or percentage of the overall heat transfer coefficient. So let's make just first make a chart. That will be very easy. If we just read out the numerical, it becomes very difficult, but when we just write the make the chart, it becomes very easy numerical. Now from the starting to end, we just write the construction material name. The outside surface consists of air of 24 km/h wind. Okay, here we have a resistance value of due to the convection over here. The wood bevel lap sliding. This is wood bevel lap sliding. The resistance value will be due to the conduction. Then wood fiber glass, this is the wood fiber glass 13 mm. Again this is the resistance value due to the conduction. And then glass fiber, again due to the conduction. In some cases there will be the vacant space. So if we have a just vacant space, here is also a good insulator, have a very good insulation value. So if we are if it is a vacant space, we take the value of resistance value of convection, like still air. As we take just outside air, we will take still air convection heat transfer overall resistance value. Then again wood stud, wood stud will not coming over here. The heat transfer is wood stud is over here. So when we just write the wood stud, there will be no R value of glass fiber. Okay, and the value of the, and when we talking about the glass fiber, we will not take the resistance value of wood stud, because we are calculating two heat transfer. One is in this direction, one is between the glass fiber, and one it is between the stud. So we just take no value in wood stud portion, but the value of wood stud heat transfer due to the conduction. Again, a gypsum wall board is common for both, and the inside surface air is still. Now we have to extract these values from this graph. Like first of all, we have a outside surface time 25 kilometers, so it is common for both glass fiber and wood stud. So we just write on both sides, and this is the value from this. The outside surface winter value will be 0.030 resistance value. This is the resistance value, so we just write over this 0.03. Then wood bevel lap, this is wood bevel lap sliding, have a R value of 0.14, so we just write the R value 114 over here. Then fiber board, this is fiber board. The fiber board, yes, wood fiber board value is 0.23, so we just write 0.23 on both sides, in this portion, these are the common material. Now the glass fiber, in the glass fiber there will be no wood stud in between, so we just take the glass fiber value. So we just see the glass fiber value. Insulation 25 millimeter is 0.70, but we have insulation of 90 millimeter. Okay, 90 millimeter. So we can easily calculate the value of 25 millimeter is 0.7. So we can divide 0.7 by 25. So 1 millimeter of insulation give 0.028 value of R. So we have we can multiply by 0.028 with the 90, we get the value 2.52, but here it is written 2.45, so it's okay. But you in paper, when you are solving this numerical, you will take the value 2.52, the actual value. Okay, I don't know why they're taking 2, it is very small value difference, but they should take 2.5 value. Okay, so the at stud, between the stud, we just write nil, because there will be no insulation between the glass fiber portion. When we are talking about the wood stud, there will be no glass fiber, but the value of wood stud resistance value. So wood stud resistance value is where it goes, yeah, like this, 0.63. Wood stud 2 inch. The same wood stud is all over here, 13 millimeter by 90 millimeter, so we take value 0.63. Then gypsum wall board is common on both. So gypsum wall, this is the basically gypsum board. So we just have a value plaster or gypsum board 13 millimeter half inch is 0.079. So we just write this value 0.79 over here. Then inside we have a still air, we have not any moving air. In winter we are not running fan inside our room, so there will be still air in the winter. So the resistance value of the still air is 0.12. You can see that these are the values with respect to units of SI units. If we are taking values in British systems, we have to take this these values. Okay, so we can write 0.12. Now we have a heat transfer between the glass fiber and heat transfer between the stud. So we just calculate both resistance values between the glass fiber and stud. We just sum all the values, it gives 3.05, and between the stud the heat transfers take place 1.23. okay, not resistance value. So you can easily understand that resistance is inversely proportional to heat transfer. So the heat transfer between the glass fiber will be lesser than compared to the stud. Okay, so the common question comes, why we are using stud over here to join this plate? If we had not used this stud, how can we join all these plate together? Okay, so it is our limitation to insert a stud over here. Anyway, we just add the resistance value of both between the glass fiber and stud. It is 3.05, it is 1.23. Now the U factor will be inverse of resistance, so 1 over R will be 0.328 and 0.813. Now area fraction, as told in the numerical, the area fraction is like 70% area covered by the glass fiber and 25% by the stud. So we just multiply this value with 75% and this value with 25%. Now we get we just multiply by this 0.38 with 75% and this by 25, and if we add, we get the overall heat transfer coefficient between all the walls, and if we convert this value, it comes 0.449 watt per meter square degree centigrade. And if we make a reciprocal of this 1 over U, we get the overall resistance of the wall, that is 2.23 meter square degree per watt. Now from this value we can easily calculate by this formula, either by this formula or either by this formula. You can also write the value of U, A, temperature difference. The inside temperature is 22, outside is -2, and we get the overall heat transfer coefficient value multiplied by area. We can calculate the heat transfer rate of the walls, and if we can also calculate the overall heat thermal resistance, so we can take this formula as well as. Okay, now we have to calculate the area. The perimeter of the building is 50 millimeter and the height of the wall is 2.5. Perimeter is basically what? Sum of all side. Like if we example of a room, we have 4 walls, so 50 means it is a sum of all walls distance. Like if we have a square room, it will be like 13.5, 13.5, 13.5, 13.5, sorry, 12.5. 12.5 is 25 and 12.5 is 25. So if we sum the 4 side of the walls, it becomes 50. So I just giving you idea, you just don't need to imagine what will be the sum of all perimeter. I just understand, try to give understanding how the perimeter is calculated over here. So it is the length of all side of the rooms, and if we multiply by the height, we get the area, and the height of the wall is 2.5 meter. Now noting that glazing constitute 20%. So if we just multiply by this thing, we get the value of overall area of the room. So we have to minus the area that is constituted with the glazing, that is a 20%. So whatever will be the answer, we should multiply by with 80%. So we just neglect that 20% of the area that is considered by the glazing. So the perimeter multiply by height give the area, and when we multiply with the 80%, so it gives 100 meter square area. Now we can take both formula, whether UA Ti minus To or A Ti minus To over R. So here we take the formula of overall heat transfer coefficient. So the U value overall heat transfer coefficient is 0.449, the area is 100, the inside temperature is 22, the outside temperature is -2. So we just calculated the heat transfer, overall heat transfer of the room. Okay, now after this numerical, the whole heat transfer portion will be portion is end. So the heat transfer portion ended over here. I just give you some uh, homework. Very next to this numerical, we have a example of this masonry wall. In previous numerical, we have done example of wood structure wall, and now we have a numerical of masonry wall that is constructed in Pakistan. And also they have insulation of a cavity bricks that is providing the insulation of a air, and also with the insulation between this air gap between this lab. So you have to calculate this with the British units. Like in the table we have both unit, meter and also British units. So you able to calculate in both units. So whether in the practical in your practical exposure, whether you have a construction material units and British units, you also familiar with that table, and you can easily calculate the heat transfer and can easily differentiate what material should be needed and what is should be the optimum in case of your construction in your practical life. Okay, like in practical in Pakistan, the Jamlon board easily available in the market. You can also calculate that after putting the Jamlon board, how much the heat transfer will be reduced. Before the Jamlon board, we have a very high value of the heat transfer in summer as well as in the winter. But by putting this, how much it reduce and how much will, then you also did the numerical by calculating that if we maintain that temperature, how much energy it will be lost due to this insulation. So you can easily convince your clients to use that insulation to have a better thermal efficiency of the building and better operational cost, to reduce the operational cost. Whether the construction cost increase, but that increase of construction cost will be overlapped in 6 months or 8 months, and after 8 months you are getting advantage of insulation and have a low operational cost of your building by running your air condition at a lower value of energy. So these are the example, or these are the advantage of this numerical. You can calculate by this calculation, you can easily convince your clients. And I do want that you people should use these kind of insulation in construction. So in Pakistan we also have a very good good comfortable buildings with reduced operational cost. So person living in over on that buildings have a lower billings, have lower burden of the energy crisis that is available in the Pakistan, that is in the Pakistan. Okay, now comes towards the next big session of your basic mechanical engineering course, that is HVAC, and it is also related to the heat transfer. As you seen that from starting to end, the whole area are surrounding around. I just take the example of the buildings. The first we have a thermodynamics that have a basic information of the laws, terminologies and the basic machine. Then we just come to the heat transfer. Again we also have a basic formulas and understanding of the calculation. Now we come to the relevant point or most accurate point to your civil engineering part, construction building parts, or installing of HVAC. When you are designing any building, you also included the portion of the system related to the air conditioning. and as well as the heating inside the buildings, etc. Okay, now HVAC means, now we start this portion. HVAC means heating, ventilation and air conditioning. It is a science and practice of controlling indoor climate, thereby providing health and comfortable interior condition for occupant in a well-designed, energy-efficient and low-emission manner. Okay, the goal of the heating, ventilation and air conditioning system is to create, maintain comfortable environment within the building. Okay, now before covering the HVAC part, we have to understand the comfortable level of the human, which parameters define the comfortability of the person. Here we have a chart that is individual person. The first contact thing itself our clothing and activity level. Okay, if we have, like for example, if I have a building of a office, we have a very low activity level because we are sitting in the computer and maximum we are just walking around our rooms and conference rooms, etc. But if we are talking about the gym, in gym we are doing very heavy exercises, so we have a very high activity level. And gym also consists with the central air conditioning, air conditioning systems, etc. Because in some areas there will be a very high temperature, we cannot afford those building without air conditioning. You also seen many gyms in Pakistan, in Karachi, are covered with the ACs. So it also depends upon the activity level and clothing, the first thing. Then thermal condition, including humidity. If we have a very high humidity, you see that very wetty environment, and lots of sweat is our body is producing a lot of sweat and it is not evaporating in the air, so it stick to our skin and it give very sticky feeling, very bad feeling. Air quality air quality in Pakistan, basically especially in Karachi, the air quality is very bad due to the pollution. You can easily calculate the air quality of Karachi. You can see that it is gives the value more than 100. In the developed country like USA, Canada, etc., and European countries, if the outside quality level increase more than 100, there will be announcement in TVs and radios that do not exercise outside because the quality of the level air quality is very bad. It will be harmful to your health, because if more we inhale the outside air, more pollution comes inside our body and will disturb our health system. Acoustic level, also very noisy place gives you a very bad feeling. Like for the study for a human body, uh, the we should be have a acoustic level lower than 80 decibel. If we have a acoustic value more than 80 decibel, it will affect our ear system. Okay, in industry there will be noise of machines, so we have a meter in where I was working, like in General Tire, in English Business Manufacturing Limited. We have a meter that calculate the acoustic level, and we do not allow the operator having a acoustic value more than 80 decibel, because it damage their ear system forever. Lightning, of course, lighting we have units of lumens. Physical, architectural, furniture, psychological uh, activity level. And due to this environmental conditions, the person will give productivity, symptoms, the rating of the space, etc. And these the comfort level with the individual, it correlated with the health. As I talk about the air quality, if the air quality is bad, it affect the health. If the thermal condition is not good, uh, continuously we have a low temperature or high temperature, it affects our health. And also it is correlated with the vulnerability and expectations. The person which having a good environmental condition give very good having very high activity, health activity and expectation and vulnerability. and then he will able to give very high productivity. Attribute of this of the spaces on the left, characteristic of the individual on the right, clothing activity of the individual as the high center. So the left side gives the attribute related to the space, right side give the attribute of the individual person, characteristic of individual person that becomes their part, and clothing having its own decision making. It doesn't. Okay. So these are the characteristic. All these due to this environmental condition, the body left. It means that it damage the emotional condition of the person, or its emotional sense, the thermal condition. You also see many ads that are related to the fan. When the fan opens, the person emotional uh, emotional condition becomes good, so its mood becomes good. So these are the in space condition depend upon also gives mood to the person. If the thermal condition is very good, the person mood becomes very good. But if the thermal condition is not good, very high temperature, it becomes the person becomes very frisky and shouted on many things, the etc etc. Anyway, now it is 30, the lecture becomes of 31 minutes. So we will cover this from the slide number 14. We will cover in the next class. Till then, Khuda Hafiz. Thank you.